Hi, this is Mrs. Ziegler, and I'm going to go over the gas laws that you need to learn. So this is the sheet where we went over in class, and I'm going to explain the understanding using some visuals. So we're going to start with Boyle's law. So remember, here, Boyle's law is where the mathematical equation is P1 times V1 is equal to P2 times V2. What that means mathematically is that pressure is inversely related to volume. What that means is when pressure increases, volume will decrease, meaning the opposite will happen to the other. If pressure decreases, then volume will increase, with temperature staying constant. To visually show this, I'm going to show you a simulation. So here I have gas particles. Temperature is going to stay the same, meaning that the speed of the particles are going to stay the same. So remember, pressure is the wall collisions, the number of times that the particles hit the wall. So volume is the space. If I if I make the space smaller, meaning I'm decreasing the space, what happens to the pressure? Well, if the space is smaller, the speed of the particles are the same. I'm going to hit the sides of the wall more often, so therefore my pressure is going to increase. Same idea as if I make my space bigger, again, not changing the speed of the particles, the sides of the wall will not be hit with the same amount of particles because, again, the speed hasn't changed, so therefore my pressure decreases. Okay, that is Boyle's law. So when looking at the formula, so again, looking at the formula, if you have pressure with these units, then and volume, which can be any of these units with temperature being the same, then you have Boyle's law. Again, pressure is inversely related to volume. So whatever happens to one, the opposite will happen to the other. Charles' law, you see here, is volume V1 divided by T1 is equal to V2 divided by T2. The ratio of two variables are equal to constant means that they are directly related. Volume and temperature are directly related. What that means is if volume increases, temperature will also increase. If volume decreases, then temperature will decrease because pressure is what stays constant. Okay, so again, when we look here, so I'm going to reset. I'm going to put some particles in there, and I'm going to keep my pressure as being constant. Okay, so my pressure is going to be constant. Okay, so I'm going to increase the space. So again, if you think about what pressure is the collisions on the wall, whereas volume is the space. Okay, so if I actually, let me do this. So if I increase the space, okay, if I make the space bigger, but I need to have the particles hit the sides of the wall with the same amount, that means that my temperature has to increase because I have to speed up my particles in order for it to hit the wall with the same amount of collisions. If I make the space smaller, again, needing to keep the pressure the same, my temperature has to decrease because I have to slow down the particles in order for it to hit the wall the same amount. Okay, that's Charles' law. All right. So when you're looking again at Charles' law, you will see that if I have volume or units of volume, units of temperature, the thing we have to remember about temperature is that if they give it to you in degrees Celsius, you have to convert it into Kelvin. Okay, on your note sheets, and I will have it written on the board how you convert Celsius into Kelvin, which is just adding 273. All right. Last law, Gay-Lussac's. Again, when you look at the formula, which is P1 divided by T1 is equal to P2 divided by T2, you should see that is very similar to Charles. The only difference is instead of volume and temperature being directly related, volume stays the same. Pressure and temperature are directly related. So again, what that means is if pressure increases, temperature will increase. If pressure decreases, temperature will decrease. So again, we're going to look at a simulation. So I'm going to put some particles in there. Okay, so again, I'm going to keep the volume is going to be constant, meaning the space. Okay, so if I increase the speed of the particles, okay, so I'm making them go faster. Okay, so that means that if I'm making them go faster, that means that they're going to hit the sides of the wall more often. So therefore, the pressure is going to increase. Okay, because again, same amount of space. If I decrease the temperature, that means I'm slowing down the particles. That means that my pressure is going to also decrease because again, if I'm slowing the particles down same amount of space, I'm going to hit the sides of the wall less because I'm not moving as fast. So I visually showed you how the three different laws are represented. Again, mathematically, you'll see here that you have when you have units of pressure and then units of temperature, again, if your units of temperature in degrees Celsius, you have to convert them into Kelvin. Okay, if you have any questions, please reach out. Remember, you will have a quiz on the math portion of this next Friday. This Friday, you will have a quiz on understanding the concepts of how these variables are related to each other.